Well, good morning, everyone. It's great to be here and have a chance to talk about the work that we're doing around, we call it the visual cloud, and maybe a slightly different focus for our talk than what you've seen so far. Really, I'm going to talk about some of the building blocks and technologies that we're working on to help you all build solutions and to build great products. So let's get into that. So, I don't think it's any surprise to you that visual traffic is driving the majority of traffic on the internet. It's 82% of consumer internet traffic today is somehow related to video or a visual data, 75% of mobile data. Netflix crossed 130 million subscribers. Live video, we saw a great example of that just before the break, growing dramatically and expected to become, 13% of all the traffic on the internet over the next few years. So we kind of think of all of this stuff as being driven by what we call the visual cloud. And when I say that, I'm really just talking about, all of the server infrastructure that it takes to deliver those experiences. And we'll talk a bit more about some technologies we're working on that you can use to build those applications. We all know the applications, video streaming, live video, gaming is coming, cloud graphics, immersive media, bringing AI into that mix. There's lots of existing use cases driving that dramatic amount of data. And there's a lot more to come. And underlying that, there's some very serious computation required to do all of this. Transcoding, encoding, decoding, doing inference, doing training. And I'm going to talk a bit about some of the tools that we're working on, that we're bringing out into open source to help scale that, to help you take those building blocks, build your own great solutions, deploy them at scale, and to really drive the next wave of innovation forward across all of these different use cases. How many of you had a chance to see our little demos out in the booth area? Well, a few of you did, good. So just a couple of examples that have been built using these building blocks, kind of fairly simple but illustrate what you can do. The first one is inserting AI inference, into a live video stream. So this is kind of a classroom example. You can imagine a classroom full of students and you have a video camera, and you're really looking at facial recognition and trying to judge are the students engaged or not. Maybe it sounds a little bit a Big Brother-ish, but there's actually some schools in China that are doing this today. Not only doing this, they actually give the parents access to the video feed as well, so they can watch along. So it may sound a little weird here, but it is really being done in China as an example. The other one that we showed is more of a gaming example. So a couple of game players playing a WEBVR game, using the web for that, and then using WebRTC to actually stream that gameplay to a spectator. So if you go out and look at the demo, you can put on a headset and you can watch live that gameplay, and you can use head gestures to choose different perspectives that you're seeing of that gameplay. So just a couple of examples to kind of show some of these new use cases built using the building blocks that I'm going to talk about. So what does it take to build this? Obviously it takes great hardware, and we build a lot of that. But most of the complexity and the innovation is really around the software. If you think about the WebRTC stack and doing inference and training and doing all this transcode, that's all software. So software is obviously essential to deploy and scale this, but even more than that, I think that open source software is essential. I've worked on open source at Intel for 20 years, and I've seen it go from something that was very much a niche and emerging into really the foundation of all of the cloud. The cloud is built on open source. It uses Linux, it uses open source virtualization, it uses Kubernetes, it uses TensorFlow, and on and on and on, right? There's a whole bunch of open source software there. And more than just having open source building blocks, the whole development model, we kind of call this the modern software development model, is built around source level continuous integration and continuous deployment, which I'm sure is not a surprise to any of you that are building cloud infrastructure. And we really believe that the most efficient way to scale this is to bring out our technology into open source so that it integrates efficiently into what you're trying to build. We know through painful experience that integrating binary software into those workflows is not easy. There are occasions where there will be some binaries, but we really do want to make this open so that it can scale and that so you can innovate on it. I think that's the other thing we've seen, amazing innovation around open source when everybody gets together and works on cool new use cases and models. So that is kind of what I'm going to talk about for the remainder. What are we bringing out that's new to open source? We just released actually a transcoding technology, and I'll give you a little bit more detail on that, and also where you can go to find out more and start playing around with it, hopefully. So we have a collaboration suite for WebRTC. As Chris mentioned, we've been working on this for a few years. This is out and available. You can go to the Intel website and download it. It's an end-to-end solution. It's got a fully featured media server that does conferencing and transcoding and streaming. We have a rich set of client SDKs for all of your favorite platforms. There's a JavaScript SDK, Android, iOS, and Windows. And we've just recently plugged in an analytics piece using another toolkit we have called OpenVINO, which again is a building block that gives you access to underlying hardware accelerators for doing inference, for example, doing video inference in particular. And this has been out for a while, and it's actually been deployed in production around the world. So this is a battle-tested solution, but it's not open source today. And that's really what we're going to change. So we're going to bring this out as open source over the next couple of quarters, starting later this year. Everything that we've done to build this framework, we're going to bring it out in a new open source project, starting with the client later this year, and then moving forward with all of the server components first part of next year. So we'll have more to say about exactly where that will be done, but we'll do it under a permissive open source license, probably Apache. We're still finalizing the exact details, but it'll be there for you to go and innovate, to build products on. We're still going to deliver this in product form for any of you that are using the collaboration suite and like that. We'll take the open source project and we'll still deliver it in an integrated fashion. But it'll be there as open source for you to go use, deploy, and contribute to, hopefully. You can see a couple of examples of things that are plugged into this, and I'm going to talk more about the scalable video technology in a minute. This is our newly opened framework for doing transcoding. On the analytics side, as I mentioned, we have our OpenVINO toolkit, which is also on its way to open source. Parts of it are open already and will be fully open over the next couple of quarters as well. And this is what gives you the plumbing down into the hardware accelerators. So I think a lot of great capability here for you to take and innovate around and build cool products on. And that's really our desire. So let me switch gears and talk about the transcoding piece. So as you saw here, this plugs into WebRTC as an example. It can be used in other places as well. And the framework is designed to be codec agnostic. So really what we set out to do is to build a great framework for highly efficient, highly performant transcoding. We've taken a lot of effort to optimize it on our CPU platforms, so it performs really, really well on top of our Xeon platforms. If you think back to that visual cloud and you want to deploy a server infrastructure to do WebRTC and video transcoding, we've been hard at work on this for years to get really highly tuned performance for those different codecs on our Xeon platforms in particular, and I'll show you a few data points. The first flavor of this that we've released is HEVC, but the framework itself is framework agnostic. And it, as I'll talk a little bit more about, gives you a lot of knobs in terms of transcoding quality versus speed, and optimized for our platforms. But it is open. It's under a BSD Plus patent license. You can see the GitHub link there, and I'll repeat that at the end. So you're more than welcome to go and optimize it for whatever hardware platform you like. If you have another platform you want to run on, you can do that. Just a little bit on the architecture, and I'm not going to dwell on this too much, but we've really designed this to be highly parallel and to be highly scalable. So if you have, depending on the platform you're running on and the scale of work that you're doing, you can scale this out into multiple threads. We've kind of divided the different stages of decode, encode, in a way that makes it very efficient in terms of scaling out to multiple threads and multiple processes, being able to use up a very large number of cores if you have that available, but also being able to scale down if you don't. And then on the quality side, there's actually 13 different increments of encode speed versus quality. So kind of M0 on the left being the absolute best video quality, takes more cycles to do that, all the way on the right, sort of screaming fast encoding. Takes fewer cycles, less time to do that. You know, and if you're playing around with this and you kind of have an idea of what application you're targeting, you can sort of pick something that's in the right end of the spectrum and go back and forth to see what suits you best. And if you have questions, by the way, we'd be more than happy to give you advice. The folks that wrote this are all actively involved in the project and would love to answer any questions you have on, hey, I'm trying to do this, how do I take best advantage of this framework? As you can imagine, there is a ton of technology underlying this, and if you're into transcoding, they'd be happy to talk to you about it at great detail. So what does this do in terms of performance? So this is a couple of performance examples looking at the SVt-hevc versus a couple of other existing open source codecs. So HM16 and X265 are both existing implementations of HEVC that are out and open. And this was looking at a 4K video, judging both speed and quality. So on the speed side, you can see 70 to 180 times faster. So really dramatically faster performance than sort of the reference open source codecs that are out there. This is screaming fast. We've spent a lot of effort optimizing it on the Xeon platform to get this. And at the same time, the quality is the same. So if you look at the mean opinion score quality, it's basically even with those codecs, but dramatically faster. And that's really what we're all about. How do we help you deliver this capability with great performance, you know, on our platforms? HEVC is only the first step. The next thing we're going to release is an AV1 flavor of this. We've already been benchmarking this internally, and you can expect to see similar performance improvements, dramatically faster. We know the innards of our architecture obviously better than anyone and how to optimize to get the absolute best performance out of it. So this will be coming also first part of next year out into the open. So I think between WebRTC, the scalable video encoding, OpenVINO, and our hardware platforms, hopefully we're giving you a great set of open source tools that you can go build cool stuff with. That's really why we're doing this. So just to summarize SVT, I think I hit most of these points. SVT itself is format agnostic and designed to be highly parallelizable and highly performant. We're optimizing it to the maximum on our Xeon platforms, but it is open source, and you can do your own optimizations on whatever platform you'd like. All about helping to scale the visual cloud and to help enable all these new workloads at scale, at really dramatic scale. If you're interested in WebRTC, you can go play around with the product as it sits today to get a sense of what it does if you haven't tried it. It's not open source, but it's a free-to-use download, so you can go to the link or just Google Intel WebRTC and you'll find it as a first hit. We'll be talking more about the detailed plans of the open source flavors over the next few months as we bring out the client version in Q4 and then the rest of it first part of next year. So we'll give you more information on that. The HEVC codec is out on GitHub now, and we'd love to hear your feedback on what you like and don't like. You can obviously use this if you're doing this type of transcoding, plug it in, and we're happy to hear about issues, questions. We'd love to see contributions. It's, you know, the usual GitHub mechanisms to do that. And we have a mailing list for AV1 if you want to track the details of when that's coming. Please subscribe to the mailing list, and we'll keep you up to date on when that's out and available. So with that, I think that's it for content, and I'm happy to take any questions you have.